Hey guys, thanks for tuning in. I wanted to make a little video for you, just with a couple examples of graphing some parabolas, where we just talk about all of the new vocab and hopefully the big picture. Even if you're feeling pretty good about it, work on speed, accuracy, getting through them quicker, using some of the shortcuts, the patterns. And if you're still a little bit frustrated trying to make it work, just pause the video, slow down, and kind of process everything as we go. So, without further ado, let's dive right in. Let's graph y equals x squared plus 4x minus 5. A couple things that instantly stick out to me are that this parabola is going to have this shape, meaning it opens up, and it's going to have a y-intercept at -5. So I'm going to label stuff as I go, but 1, 2, 3, 4, 5, I'll label this -5, and I'm going to put a little y there. The next thing I personally like to do is I like to find the vertex. And the vertex, part of it is found by doing -b over 2a. So -4 divided by 2 is -2. And remember, that's half of the vertex. It's the x-coordinate. So a -2, which I'll start labeling over here, the vertex is going to be somewhere along that vertical line, but the axis of symmetry always passes through that. So we actually found the axis of symmetry already. And we can actually steal this point right here. I'll switch back to purple just so it looks prettier. And there's going to be a point right here because of the symmetry. And if there's 2 units here, there's got to be 2 units there. I'm going to delete that so it still looks nice. All right, because it opens up, I'm guessing that the vertex is going to be somewhere down here, but we actually have to find that y-coordinate. So, best way to do that is to essentially take our quadratic, x squared plus 4x minus 5, and I'm going to plug in my -2. And that's going to give me the y value that's associated with that x value. So I got 4 minus 8 minus 5. And it looks like I have -9. So the full-on vertex is going to be -2, -9. So I think it's going to be down here. So you can kind of see the U shape coming up. This point I just found down here is the vertex. And I believe it's going to kind of come down through these guys. Come back up. And I've already got a decent graph. But just to make it a little bit more thorough, one nice thing that is pretty important just in terms of some characteristics is the X intercepts. You know, where does this graph cross here? And that's one of the things we're emphasizing here at the end of the week. And remember that every X value, I'll write it down because it's that important. Every X value, actually, let me rephrase that. Every X intercept has a y value of, you guessed it, 0. No matter where you pick, no matter what your x-intercept is, any of these values, what they all have in common is they all would have a y value of 0. So if you want to find the x-intercepts, again, you can kind of estimate them, right? They're going to come up and hit somewhere in there, right? What value is that? Well, let's find the exact answer. And so we can take our quadratic, and we know this is equal to y, but we're saying that if y is 0, we're going to have some values that make that true, and those values would be the x-intercepts. And this should make you raise an eyebrow or smile or say, oh, okay, I get it. Because this is the type of problem we did with factoring or with quadratic formula. And factoring is nice if it is factorable, because you can get there quick. And excuse me. If you can't factor it, you can use quadratic formula to solve the quadratic that way. And so I think I can factor this one. That's why I paused, because I was thinking about what the factors would be. I think 5 and 1, you can make a product that's 5. And if you set this equal to a positive 5 and this equal to a negative 1, I think that factor will work. Now, to solve it, we need to set each factor equal to 0 because of that zero product property. Some of you might do these steps in your head. Just be careful. You want to make sure your answers kind of make sense on the graph. So when it says x equals 1 and x equals negative 5, these values, these points that I'm drawing right now, these are x intercepts on our graph. Let's see if it makes sense. It says there's 1 at 1. I'll label it as I go. And it says there's 1 at negative 5. 3, 4, 5. Are they equal distant from the axis of symmetry? 1, 2, 3 units. 1, 2, 3 units. They are. Seems reasonable. Let's see if I can make it pretty. Oh, baby, look at that. It's almost worth taking a screen capture just because it's so nice looking. No, it's a work in progress, but I think that's pretty accurate. And I've got my X intercepts. There's 2 of them. Got my other X intercept. I've got my vertex labeled. I got my axis of symmetry. It's opening up. I think I got a pretty accurate graph. Awesome. Let's try to cram in one more example here before I reach my time allotment. All right, I'm going to go a tiny bit quicker with this. Here we go. The y-intercept is negative 3. That's a gimme. That's an instant if it's in standard form. This is going to be going down this time. Vertex is negative b over 2a. Ooh, we got a fraction, so we got 5/4. And I don't know the, I don't know the y-coordinate yet. But 5/4, if this is 1, and this is 2, 5/4 is going to be somewhere in here. All right, so I could plug in 5/4 into x, and it's going to give me some fraction. So I can do that. In fact, let's at least set that up to see how nasty it is. So if I do plug in 5/4, let's write it correctly. Whatever this ends up spitting out, negative b over 2a, so I didn't mess it up, that's going to give me my y-coordinate. In the meantime, if I look down here, I also could take this point and reflect it across. So it's a little over 1. So it's going to be, somewhere in here. And because it's going down, because that a value is negative 2, my vertex is going to be somewhere probably up here. Maybe up a little higher. Again, we're not sure how skinny it is, how wide it is. To know that exact value, I'd have to finish this problem. So let me at least work in another step or two. Hopefully something comes out nice. We got this. We got this. We got this. So I got negative 50 over 16 plus 100 over 16. If I do a common denominator, multiply top and bottom by 4 over 4. And again, if I need a 16 here, I'd have to do this. That's 48. So this is not ideal, and this is where you just got to be careful, I suppose. So I've got 50 over 16 minus 48 over 16. After all that work, it looks like I've got 50 minus 48 over 16. So it looks like I have 2 over 16, which is 1 over 8. So it looks terrible, but actually ends up being right up here somewhere. So if this is 1, it's going to be between 0 and 1. So I've already got a decent graph, and I don't think this is going to hit at integers. I think it's going to hit the x-axis, because again, it's got to go down like this. And we might be able to factor this, but just as kind of review, remember that we can also find x-intercepts by using the quadratic formula. And it works the same way as if you set it equal to 0. And identify A, B, and C, A, B, and C, and plug them in. Whatever x values that it spits out, I'm trying to shrink this, not working. Whatever x values it spits out would be the x-intercepts. And so we'll also review on the way how you can figure out, oh, could I have factored that? And so here we go, quadratic formula, x equals, again, what x? The x-intercepts. Negative b plus minus b squared minus 4 times a times c divided by 2a. Negative 5 plus minus 25 minus times a minus times a minus is a minus. 4 times 2 times 3 is 24. Oh, that actually works out nice. X equals negative 5 plus minus the square root of 1. Negative 5 plus 1. Negative 5 minus 1, if you don't like the plus minuses. So what do we got here? We got negative 4 over negative 4. So one of the answers is 1. And we got negative 6 over negative 4. So our other answer is 3/2. So a couple things just as a reminder. Where are these on the graph? Well, it's pretty accurate, but it's saying, come on, dude. If I highlight them in pink, it's saying that if this graph was perfect, one of my intercepts would be right at 1. And the other one would be at 3/2, which would be actually a 1.5. A little bit more accurate as if we had those hitting in the right spots. Now it just looks bad. So I'm going to leave them with pink. But you can see that they fall in the right area. Another reminder is just we've talked a little bit about the discriminant, and that value b squared minus 4ac. In this case, it's equal to 1. And what that means is, one, it's going to have two positive x-intercepts, because that's a positive number. And there they are. They're in red. The values are actually right there. More specifically, though, because it's a perfect square, right? Talked about perfect squares. I'm writing them quickly. I'm running low on time. YouTube cuts me off at 15 minutes. Because it's a perfect square, it means I could have factored this. Meaning if I pull out a negative and then actually try to factor this, you're going to have like a 2x and an x. And then try to figure out 3. And a 1, make them both negative. Is that right? 6x minus x. Ugh, I'm running low on time. I'll leave that as a challenge for you, because I feel like I'm going to get caught here at the end and have to redo the video. So because there is a perfect square here, we should be able to factor that, and the factor should end up leading to the same thing. Anyway, it's a nice backup plan to have. Thanks for tuning in. Hopefully this helps, and I'll talk to you guys soon.